Hi guys, today's video is going to be about factoring quadratics where a equals 1. And this is going to make more sense as we go. So first I want to review what is factoring. What does that even mean? So if we were going to list the factors of 24, that means we want to know what numbers can we multiply together to get 24. So we would have 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then 5 doesn't go into 24, so we wouldn't list it. And then I would test 6, but 6 already shows up on this side. So whenever your numbers that you're testing over here start showing up over here, when you start to repeat yourself, that means you've gotten every single number that there is. So these are all 8 factors of 24. These can all be divided into 24 evenly. So factoring is the act of turning one expression, so in this case our expression was just the number 24, into the product of 2 or more smaller expressions. So it could have been 1 times 24, 2 times 12, 3 times 8, or 4 times 6. But we're going to kind of build on this and apply it to quadratic equations. Before we get into quadratics, let's review what a greatest common factor is. You probably learned about greatest common factors whenever you learned how to convert fractions. So we want to find the greatest common factor of 24 and 36. So first of all, let's remember what is a greatest common factor. Given two numbers, the greatest common factor is the largest number that both of your original numbers can be divided by evenly. Okay? So all the factors of 24, we just listed those. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Out of 36, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 does not go, but 6 times 6 is, and that in itself is a repeat, so 6 only goes on there once. So to find the greatest common factor, that means we want to look for the biggest number that shows up in both lists, and that number is 12. The greatest common factor of 24 and 36 is 12. That's the biggest number that goes into both of these evenly. All right, so let's keep building here. What about if we have variables? How would we find the greatest common factor of x squared and x to the 5th? So a quick trick to figure out what the greatest common factor is, they have to have the same base, okay? But then you use the smallest variable of the two things that you're trying to find the greatest common factor of. So the smallest variable of these two is 2. So the GCF is x squared. And I'm going to show you how that goes into both of these evenly, okay? When you divide exponents, x squared divided by x squared. First of all, anything over itself equals 1. We know that. So x squared does go into x squared evenly. But what about x to the 5th? We have to be able to divide it evenly by x squared. When you divide with exponents, you subtract them. Okay, so this is x to the 5 minus 2, which is just x to the 3rd. Okay, and so that means that x squared does go into x to the 5th evenly. It goes in x to the 3rd times. So that might be a little bit of overkill for the information you need right now. The part that I want you to remember, the part that needs to stick in your brain, is that when you're trying to find the greatest common factor of two variables, the greatest common factor is that variable with the smallest of the exponents. So x squared is the greatest common factor of these two. Okay, so there is a worksheet that you guys are doing some practice problems off of, and these examples come from the odd problems. So whenever we are factoring polynomials just means there's more than one part. There's more than one part, so 2 parts, 3 parts, 3 parts. When we're factoring those, the first thing that we're all is check for greatest common factor. And so let's look at this. When we factor a greatest common factor out of something, this is like undoing the distributive property, okay? So to factor something out of 12k minus 18, we're going to look at each piece individually. So first we're going to look at the numbers, the coefficients. Out of 12 and 18, the biggest number that goes into both of those evenly is going to be 6. And you could list, all the factors to figure that out for yourself. But I can do this one in my head, and maybe you can too. And then we want to find the greatest common factor of k, and oops, there's no k here. So we cannot take any k's out because both of these terms do not have a k in common. So 6 is the greatest common factor, but we are just pulling that out of there. And I'm trying to think of how exactly to explain this to you. So we're going to take this piece and divide it by 6 to see what goes in parentheses here. So 12k divided by 6 is 2k, minus 18 divided by 6 is 3. So what I want you to see is that these are two things. We said the definition of factoring was to take one expression and find two other expressions that you could multiply to get this, okay? So this is our answer. This is what I want you to find, because these are the two factors. 6 and 2k minus 3 are the two factors of this expression. But to show you, to check your answer and to show you that you're correct, I'm going to distribute this back out. And if I do that, 6 times 2k is 12k, and 6 times negative 3 is negative 18. So this is the same as this, that we got the right answer. Okay? So if when you distribute this back out, it equals what you started with, then you got the right answer. So let's look at this. So the question is not to find the greatest common factor. We're not just finding a greatest common factor. We're trying to factor this polynomial. And when we factor polynomials, we're trying to find things we can multiply together. So smaller things we can multiply together to get the big polynomial. So to do that, we're going to pull out the greatest common factor. So first we're looking at 14, 35, and 7. The greatest number that goes into all of these evenly is 7. Then we need to look at the variables. We have m to the 6th, m to the 3rd, and m squared. Remember, whenever we have variables, we always can pull out the smallest exponent worth. So part of our greatest common factor is going to be m squared, because 2 is the smallest exponent. But then we need to know what can we multiply 7m squared by to get this thing that we started with. So let me erase some of this stuff that's in the way. It's getting a little jumbled. And let's see what we've got here. So 7m squared, we want to take each piece and divide it by what we said our greatest common factor was. Okay, so in the first one, we have 14 over 7, that equals 2, but m to the 6th over m squared is m to the 4th, because we subtract those exponents. 6 minus 2 is 4. So then we have Negative 35 over 7 is negative 5. M to the third over m squared. 3 minus 2 is 1, so we're going to have m to the first. But when our exponent is just a 1, we don't write that exponent. We just leave it as a plain variable. And then anything divided by itself equals 1, so we have minus 1. So this is the factored version of this polynomial. And if you wanted to check your answer, just to check and make sure you were right, you could distribute this back out and see if you got what you started with originally. All right, this next one, it has stars on it because it's not part of your worksheet, but it is important to being able to do some of the practice problems that you're gonna have to do tomorrow. So it is important to pay attention to this one, but it's not on your worksheet for today. All right, so we are looking for the greatest common factor of all 3 terms. So first we look at the coefficients, 3, 18, and 12. The biggest number that goes into all of those evenly is 3. Then we need to look at our x's. So you're going to take these have more than one variable. We're going to take each variable independently and look at it, okay? And then we'll come back and look at the next variable. So all 3 of these have an x in them. Remember up here, not all the variables had k's, so we couldn't take any k's out, okay? But down here, all 3 have an x in them. The smallest variable is in this one, and it's a 1 because when there is no variable, or when there is no exponent, it means that that exponent is actually a 1. So we can only take out x to the first. Remember, when it's to the first, we don't write the exponent. Okay, now let's look at the y's. We have y here, and y here. So there are y's in all 3 terms, so we can take y out, but to what power? The smallest power is a 2, so we can take out y squared. Then we need to figure out what we can multiply 3xy squared by to get the thing that we started with. We need to figure out what the other factor is. So we have to, in order to do that, we're going to divide every term by 3xy squared. All right, so 3 divided by 3 is just 1. X to the 5th divided by x is x to the 4th. And whenever our coefficient is a 1, we don't actually have to write that coefficient. Okay, so we can erase that. And then y squared divided by y squared is just 1. So we don't have, all we have in the first one, these cancel and these cancel, left with x to the 4th. So we've taken care of that term. Now 18 over 3 reduces to 6. X over x is going to cancel out because that just equals 1. And then y cubed divided by y squared is just y. So we took care of that one. Negative 12 divided by 3 is negative 4. X squared over x reduces to x. And then y to the 5th divided by y squared is y to the 3rd. So we took care of that term. So now we have this, which is our factored version of what we started with over here. So if we wanted to check our answer, we could distribute this through every term. And we would get this back. Okay? So you'll see that the first couple of practice problems, all you do is take out a greatest common factor, and that's it. Now we're going to get into the part that we will use a lot. And that is actually factoring quadratic equations. So let's just remember, let's refresh our memory. Standard form of a quadratic function is ax squared plus bx plus c. And we can use f of x equals, and that's just function notation. And it's exactly the same as saying y equals. So we put it in y equals form when we're trying to graph, because we graph using x and y axis. And then if we're trying to find a solution or find the zeros of an equation, we put it in 0 equals form. Okay, we make y equals 0. So now that we've refreshed our memory with ax squared plus bx plus c, we're going to talk about how to factor those. We can use factoring to solve quadratic equations. We're not going to start solving for x just yet. Right now, we're just going to practice the act of factoring. So we're going to have expressions, not equations. That means there's no equal sign, so there's nothing to solve for. So at first, we're going to learn how to factor expressions where a equals 1. So instead of ax squared, it's just going to be 1x squared, but we don't actually have to write that 1. So we're going to have x squared plus bx plus c. And we're starting with these because they're easier. We're going to learn how to do ones where a is greater than 1, but that's for another day. So let's just get into the practice, because none of this really means anything to you until we start applying it. So this is number 7 on the worksheet that you're going to use to practice. So when we factor, the first thing that we are going to do is check for a greatest common factor. So we're trying to split this quadratic expression. Remember, it's in x squared plus bx plus c form, okay? We're trying to factor it into 2 binomials that we can multiply together to get this. And binomials mean they have 2 parts. So our answer is going to look like 2 sets of parentheses, and we're going to have a c here and a c here. And then it'll be plus or minus something, okay? But the first step in that is to check for a greatest common factor. Okay, so first we look at coefficients. This is a 1, a 2, and a 48. Well, the only thing that goes into 1 is 1, and if we divide all these by 1, it doesn't change anything. So you can't take a coefficient out. But what about a variable? We have a c here, a c here. Oh, but we don't have a c there. So there is no common factor between these 3 terms. So we have done that. We've checked for a greatest common factor. Now we're going to set up our binomials. And that's what I kind of started to do a second ago. So for our binomials, we're going to set up parentheses. We want to split this trinomial into 2 sets of parentheses. Okay? And remember, this method that I'm teaching you is only for quadratic trinomials where a equals 1. So quadratic means that the highest exponent is a 2. And trinomials means that there are 3 parts. 1, 2, 3. And then a equals 1 means that there's no coefficient here, because it's just equal to 1. It has to satisfy all of these to use this method. So we want to separate this into 2 binomials, and each of them is going to start with a c, because variable is. And then, so we've done that. We've set up our binomials. That's all we have to do for that. And then we are going to choose our factors. And I should have put another step in here. We need to first choose our signs. Okay? So we need to know if this is going to be a plus or a minus, or 2 pluses or 2 minuses. We need to choose, okay? And the way that we choose that is our 2 numbers have to multiply to get negative 48, and they have to add together to get positive 2. So if 2 numbers have to multiply to get a negative, okay, here are our options. We can either have plus plus, or we can have plus minus, or we can have minus minus. So when you multiply two positive numbers together, you get a positive number. When you multiply a positive and a negative, you get a negative. When you multiply two negatives, you get a positive. So we need to multiply to get a negative number. That means we have to have one positive number and one negative number in our factors. And it doesn't matter which order you put the plus and the minus in right now, okay? So, but we know that we have to have a positive and a negative number. Now, we need to figure out what factors we can get to multiply to get C. So C is negative 48, and add or subtract to get A. That's supposed to be B. Wow. So add or subtract to get B, which is positive 2. So whenever we have addition and subtraction, one factor is going to be positive and one's going to be negative. That means that whenever we list all the factors of 48, let's actually not do that. So we want to list the factors of 48. And then we need to know what the difference of those factors is. Because when you add a positive and a negative number, so if you have like 5 plus negative 3, you're actually doing 5 minus 3, which is 2, okay? So we need to know what the difference in the factors are. So 48 has 1 times 48. The difference in those is 47. We have 2 times 24. The difference in those is 22. We have 3 times 16. The difference in those is 13. 4 times 12. The difference is 8. 5 does not go into 48. 6 does. 6 goes in 8 times. The difference is 2. And then 7 does not go into 48 evenly. The next number I would test is 8, but I've already used 8. When I start to repeat myself, that means I've got all of my factors to choose from. So these are all the factor pairs I can choose from that equal 48. So I need to be able to add those together to get positive 2. So we know the signs are going to be different. So we need them to equal positive 2. In order to do that, we need to make the 6 a negative. Negative 6 plus 8 equals positive 2. So up here where our negative sign is, that's where we're going to put our 6. And our 8 goes in the other one. Now, this is a lot of information up front. It's going to make a lot more sense the more we practice it. And we are going to practice this a lot, okay? This C plus 8 times C minus 6, that is our answer, okay? C plus 8 and C minus 6 are the two factors of this trinomial. But we need to learn how to check our answers. Because when you get used to doing this, all your work is going to look like, you're just going to be able to say, okay, parentheses, here's a C, here's a C. They have to multiply to get a negative, so I have to have two different signs. And then I'm asking myself, what two things can I multiply to get 48 and add to get 2? Oh, 8 and 6 have a difference of 2, so I can do positive 8 and negative 6. So positive 8 times negative 6 equals negative 48. Positive 8 plus negative 6 equals positive 2. All done. That means I've done my job correctly. Oops. Okay, so you don't have to show a whole bunch of work in these problems. So I'm not going to give you answers to these to check yourself. So you need to learn how to check your own work. Okay, so here's your answer. How do I know that's the right answer? When you multiply two binomials, okay, we decided that factoring means finding two things you can multiply together to get this trinomial. So we need to test if we multiply these together, do we get this trinomial? And the way that we're going to do that, it's called the FOIL method. Okay, so F F-O-I-L. And F stands for first. So you're going to multiply the first terms of each binomial. So C times C. That equals C squared. All right. Then we have the outside. O is for outside. So we want to multiply C times -6, the outside terms. So C times -6 equals -6C. Okay, then we want to multiply the inside terms. That's what I stands for. So that's 8 times C. 8 times C. That equals 8C. Then L stands for last. So the last term in each binomial. So we have 8 times -6. That equals -48. Then we take these 4 things and add them together. C squared plus -6C plus 8C, well, minus 48. And then combine like terms, and we get C squared plus 2C minus 48. Okay, so when we multiplied these two things together, we got this trinomial, which is what we started with, which means that our answer is correct. So if you're not sure about your answer and you need to check yourself on your first few problems, you're going to use the FOIL method. And you're going to hear me pound that in your head, that when you multiply binomials, you use the FOIL method, okay? Because it's very easy to make mistakes if you don't. All right, I'm going to walk you through some more examples because I know this is new to you guys and I know it's a lot to take in. Okay, so remember, first we check for a greatest common factor. Since this coefficient is a 1, you automatically know that you can't take a coefficient out. And this term does not have an A, so we can't take a variable out. So there is no greatest common factor here. Then we're going to set up our binomials and choose our signs. Okay, so we're going to have 2 binomials. They always are going to start with our variable. And then let's look, we have to multiply to get a positive and add together to get a positive. So if 2 numbers multiply to get a positive, that means we can have a positive times a positive or a negative times a negative. Okay, so we know by this being a positive that these have to have the same sign. But we don't know if those are going to be positive signs or negative signs. So once we know they're going to be the same, let's look at what they have to add up to be. So if you have a positive number plus a positive number, that equals a positive number. But if you have a negative number plus a negative number, that equals a negative number. So since they have to add together to be positive, that means that they are going to be 2 positives. All right, so we've set up our binomials, we've chosen what our signs are going to be. So now we need to choose our 2 numbers. So they have to multiply to get C and add or subtract to get A. So since our signs are the same, then we're going to list our factors of 36, so they multiply to get C. This is C. And then if your signs are the same, then the sum has to be B, not A. 12. So we want 12. All right, so let's list our factors of 36. 1 and 36, that's 37. 2 and 18, those add up to 20. 3 and 12 add up to 15. 4 and 9 add up to 13. 5 does not go into 36. 6 times 6, that adds up to 12. And remember, when these start to repeat, we're done. But even if we weren't done, we found a sum of 12. So that means that these are the 2 factors we're going to use. So we're going to plug in a 6 and a 6. And you'll notice that these two are the same. So we can write this as a plus 6 squared. Okay, so this is correct, or this is correct. That's an R, or. Now remember, to check our answers, we use the FOIL method. So if you need to check your answer, a plus 6 times a plus 6, we multiply the first terms, so that's a times a. The outside terms are a times 6. The inside terms are 6 times a. And the last terms of each one is 6 times 6. So let's multiply these together, and we get a squared, 6a, 6a, and 36. And then we add all these together. So a squared plus 6a plus 6a plus 36 combine like terms, and we get a squared plus 12a plus 36, which is the same thing we started with, which means our answer is correct. Okay, on this one you're going to notice that when we check for a greatest common factor, there is a greatest common factor, okay? And you're also going to notice that a is not equal to 1. And right now, we are learning about factoring where a equals 1. So most likely, that means that we need to take a greatest common factor out. So if you look at our coefficients, 2, 16, and 40, the biggest number that goes into all three of those evenly is 2. So we're going to factor out a 2. That means we have to divide every term by 2. So we're going to get k squared, because those 2's will cancel, minus 8k minus 20. Okay? But unlike the greatest common factor examples we did earlier, we are left with something in here that we can factor like we have on the last two examples. So this 2 is going to come down and go in front of, so we did our greatest common factor. This is going to go in front of our two binomials. So the factored version is going to be 2 times k something and k something. So we need to also choose our signs. That doesn't even look right. Okay, so we need them to multiply to get a negative number. So if we multiply to get a negative number, they have to be different signs. They can't be the same sign, because a negative times a negative is positive and a positive times a positive is positive. So they have to be one of each to be able to get this negative that we need. Then we want to look at factors of 20. And because we have different signs, we want the difference of those factors to be equal to negative 8. Or, yeah. Sorry. All right, so let's list the different factors of 20. We have 1 times 20. The difference of those is 19. We have 2 times 10. The difference of those is 8. Whoa, we're already done. We don't have to go any further. Don't need any more factors because we found our magic number. So if we need to add 2 plus 10 together to get, we need negative 8. Which of those numbers has to be the negative one to make negative 8? The answer is 10. 10 has to be the negative number. So 10 goes with our negative sign up here, and 2 goes with our positive. And just to mentally make sure we're on the right track, instead of doing the whole FOIL method, you can just ask yourself, does positive 2 times negative 10 equal negative 20? Yes, it does. Does positive 2 plus negative 10 equal negative 8? Yes, it does. So most likely you are correct, and this is your answer. So what that means is that this expression is not factorable. So you're going to write not factorable. However, if you answer not factorable, I will count it wrong unless you show me a completed factor table. So what that means is you have to have this written out and you have to have every single factor listed before you're allowed to write not factorable. If you write not factorable and you don't have this table, I'm going to count it wrong even if it's right. Okay? All right. So I said all that junk. Let's take a look at the one on the right side. It's a little bit different. So remember, we're always checking for a greatest common factor first, and these all have a 2 in common. I can take 2 out of all those evenly. So we're going to do 2, and that leaves us with x squared plus 14x plus 12, because we divided each of these by 2. All right, and then x squared plus 14x plus 12 is this trinomial, and I did that on purpose so that we don't have to do the table again. So we know that we cannot factor this trinomial down into 2 binomials, but that on this one, not factorable would actually be wrong, because this is the 2 factors. The 2 factors are 2 and x squared plus 14x plus 12. So even though the trinomial is not factorable, this is still a factored answer because you factored a 2 out of the trinomial. Okay? That's all I've got for you today. I know it was a long video. It was a lot of information, and you're going to have a lot of practice problems tomorrow because this is a very important skill that's going to follow you throughout the rest of your math classes and the rest of this year. So we're going to practice. Please touch base with me if you need any help. Thanks so much for listening.